Lab 1, Constant Velocity. The objective of Lab 1 was to design an experiment that compares the observed and predicted motion of an object moving at constant velocity. In this experiment, the fundamental physical principle of Newton's second law of motion was used to explain the constant velocity of the moving object. Newton's second law states that when velocity is constant, net force acting on the object is zero. This is because if final and initial velocities are the same, the mass and the change in time are non-zero, therefore net force must equal zero. I filmed a video of a tennis ball moving at a constant velocity. Using the tracker program, I collected the observed data from the video. As you can see, I selected the time frame from 151 to 263. I used a calibration stick to calibrate the scale by stating the diameter of the tennis ball, which is 6.8 times 10 to the negative second meters. I also set the coordinate axis so that the ball is moving in the negative x direction. If I flipped the axis and made the ball moving in positive x direction, the graph would show a positive slope instead of a negative slope because velocity is in positive x direction, and these values will be positive as well. After tracking the tennis ball using point mass, I was able to collect a set of data on the right side. Using the glow script program, I was able to create a prediction of the motion of the tennis ball. Given the starter code for Lab 1, I modified the code to fit my model. The radius and the mass of the ball was modified to fit the tennis ball. Then, initial velocity and initial position was set to match the data by using the data points in tracker, the initial position and the final position, and the duration and time to calculate the initial velocity using the equation change in position over change in time. Moreover, I changed the net force to equal to zero because the motion has a constant velocity, and the formula was modified to fit the Newton's second law. F net over mass of the ball times delta t, and the position, initial position plus velocity of the ball times delta t. When net force is equal to zero, it means there is no change in motion. Using the data collected from tracker and glow script, I created a line chart on a spreadsheet to compare. Based on the graph, the model position is a straight line showing a constant slope, meaning constant velocity, while the experiment position also looks approximately linear with constant velocity. However, we can suggest that it has speeded up a little bit at the beginning of the experiment and slowed down towards the end. This error can be explained because when I filmed the video, the tennis ball was at rest first, and then a force towards the negative x direction was applied. Therefore, we can suggest that the ball was accelerating a little bit at the start and slowed down as it moved further along the path. Overall, we can see from the graph that model prediction is approximately similar to the experimental observation, and when net force equals to zero, the velocity is constant. Another discussion point could be that if I calculated the average velocity using the first 2 points in the tracker program instead of the entire time frame, I would have had a steeper slope matching the first half of the graph, but the plot would have shown the ball slowing down during the second half anyway. In this experiment, we set the net force to zero in the model. Net force is calculated by adding all of the forces or pushes and pulls applied to the moving object in the model. In this model, we are given the condition that the object has a constant velocity, while we do not have any other information about the forces. For example, there could be gravitational force, resistance force, and so on. More information will be needed for us to identify all of the forces. Therefore, it's impossible to identify every single forces that are added together to give a zero net force. This concludes Lab 1.